Hello again, students. In the previous video, we did some computation, but those were all very elementary computations. Let's go one step further. Okay, we had been using these rules over and over again, especially the first one. Okay, let's go. How about a problem like, oh no, excuse me, wrong cell. How about a problem like this one? Looks complicated because it's fraction. And is there a quotient rule for antiderivatives? No, not really. So what do you have to do? Well, here's my suggestion. Please take a look at the denominator. No addition there. That's a big key. If you have something added or subtracted in the denominator, then we have to use completely different technique. Here's an example. 2 over 3 plus 5. This doesn't work. This is not the same. See? They don't work like this. This is wrong, but how about this? This is okay. You cannot separate the denominator, but it's okay to separate the numerator. This is what we are going to do. So we'll separate the numerator like this. And let me use the full use of this copy and pasting function. Okay, remove all these. First done. Second term done. So what did he do? We separated the numerator. And then what we can do now is just simplify each term, and then we can apply the power rule to each term one at a time. Let's simplify the first term. The number part is 1/3. Actually, which power is it? Second power minus first power. This is just first power. Or you don't really have to write it. By the way, we are doing this. A to the m power over a to the n power is equal to a to the m minus n power. Same power rule. Now, 2/3 x over x. This time x part just cancel each other out. Now how do we work this one out? Oh, by the way, I should have converted this into the power form beforehand. Usually power form conversion is the starting point. That would have made the problem even simpler. Okay, the number part 3 over 3, that's gone. X to the what power is it? 1/2 power minus 1, so this is negative 1/2 power. Now, are we ready to calculate the antiderivative? Yeah, we are ready now. First, coefficient is 1/3. Raise the power by 1 and divide. 2/3 times x. Next, raise the power by 1, so add 1 to the power, so 1/2, and then divide. Dividing fraction is the same as multiplying the reciprocal, and it's the same as just 2, but as a reminder, I usually put 2 over 1 like this, and then take an extra step for simplification. It's a way to cut down unnecessary mistakes, by the way. I found myself mistake prone, so I went a great lengths to protect myself from stupid mistakes, and this was one of them. So what did I do? Separate the numerator, simplify each, and then the power rule. Now please note that first two lines are just algebra, just simplification, not the antiderivative rule. Therefore, the integral sign and dx stay as they are. I didn't take the antiderivative yet. I will, but I didn't yet. Now, as we take the antiderivative, integral and dx disappear at the same time, and then we get the answer. So this transition is important. Do not mix those up. Antiderivative someplace and then just algebra in another place is recipe for disaster. Sometimes you take antiderivative twice because you lost track of your time and things like those. And how do you protect yourself from those kind of mistakes? By using correct symbols, correct notations. Integral and dx, they stay as they are because it's a reminder. I didn't take the antiderivative yet. I will, but not yet. Now I took it, so they disappeared. So integral and dx disappeared, and we gained plus c. So algebra here, algebra there. Now antiderivative, algebra here. That's how the solution works. We have a little bit more time, so let's practice the same technique once more. So how do you work this one out? Okay, again we're going to separate the numerator, but this time let's not forget the power form. X times square root of x is here. Combine those, you're going to get x to the 3/2 power. Okay, let's start from there, and let's separate the numerator. Minus, plus, and then erase some. Okay, separation complete. Now the separation is now done. Let's simplify. Okay, how about the first term? 2 over 2, so the number part is 1. So you don't really have to write it. Actually, what power is it? 3 minus 2, so first power. You don't have to write 1. You don't have to write 1, and there goes the simplification. Next, 4 over 2, so the number part is 2. Actually, what power is it? 3/2 power, and then 2 power down there. So we need 3/2 minus 2, isn't it? Minus 2, excuse me. So you get negative 1/2 power over there. Finally, number part is 5/2. Actually, what power is it? 1 minus 2, so negative first power. Okay, let's take the antiderivative. Antiderivative of x, what is it? 1 of x squared. And then next, minus 2, add 1 to the power, and then divide. Just the power rule, right? Add 1 to the power, and then divide. Oh, wait a minute, I can't do this. I cannot divide by 0, so something is wrong. I cannot use the power rule. What is this? This is log of x. And that completes the problem. If you want to simplify this thing a little bit, and this one into 4, that's fine. Now let's do it anyway. Okay, there goes the full solution. So what did he do? Power form conversion first. separate the numerator, simplified, and then we took the derivative one term at a time. Now let me open up these answer keys here, and let's discuss these in terms of my answer key. And there's just a little bit of surprise. There are two solutions. Solution 1 is the one I explained as a matter of fact just now. Separate the numerator, simplify, and then take the antiderivative one at a time. So it's exactly the same as this one, so I don't need a duplicate here. Now let's open up the second solution. How does that thing work? It looks a little bit different, but in the end you get the same answer. Let me try to explain what happened here. Instead of separating the numerator, we change the division into multiplication. This 3x, especially x down there, we can bring it up as to the negative power. And then this becomes just a multiplication, so you can distribute it around. So you can draw some arcs like this, arcs, and distribute it around, and then we end up with the same simplification. Yes, you have to get same simplification. After all, these are same functions. In the end, of course, the same answer. Which method do you prefer? I usually follow solution 1, and so does our textbook author. But a lot of students prefer the second method. That's why I'm showing you both methods. Now, that doesn't mean everybody has to know both methods. If you know one method, just stick to it. That's okay. But in my experience, how many students prefer solution 1 and how many prefer solution 2? Usually half and half. I'll be more in solution 1, but about push. Let me show you the same thing for the second problem as well. First solution, the same as what we did over here, so we don't need duplicate. Separate the numerator and then simplify and then antiderivative. Second solution, this denominator 2x squared, we flip it over. 2 is in denominator, so leave it as 1/2, but x squared becomes now negative power. And then we distribute it around, same as before, and then calculate the antiderivative, same as before. Now, do we have time for the next problem set? Not really. So let's do this in a separate video.